Hey everyone, welcome back to another Linux tutorial. In today's session, we will explore a really interesting topic, Linux desktop environment and virtualization. If you are new to Linux or just starting to explore it, this video is going to be super helpful. So what exactly we are going to learn in today's session? Here is a quick overview. First, what is desktop environment in Linux? Basically how your system looks and feel. Then we will explore some popular desktop environments like GNOME, KDE Plasma, Xfce and LXQt. After that, what is virtualization? In simple terms, creating a virtual computer using software. We will also compare a virtual machine versus physical machine. How are they different? And finally, we will look at the different types of virtualization. Let's explore each step together. Let's begin by understanding what a desktop environment actually is. In simple words, it's the graphical part of your operating system, the icon, windows, menu, and wallpaper you interact with every day. It defines the overall look and behavior of your Linux system, how it feels, how it responds, and how you use it. In Windows, the graphical interface is fixed. You don't get many options to change how things look. But in Linux, you have a complete freedom. You can choose your preferred desktop environment like GNOME, KDE or Xfce and even switch later if you want. As shown in the diagram, the desktop environment sits above the operating system kernel, which then interact with your hardware. In Linux, the desktop environment is separate from the core OS. That's why you have so many choices. Now let's look at some of the most popular desktop environment in Linux world. Each one offers a unique user experience from design to performance. Let's go over them one by one. GNOME offers a clean modern interface. It's the default in distribution like Ubuntu and Fedora. It is great for touch screen and has a minimalistic design. The activity overview makes multitasking smooth. Next is KDE Plasma. Perfect for customization. Feels familiar if you have used Windows. You can choose themes, widgets, layouts, everything. Comes with rich set of built-in applications. And the next is Xfce. Lightweight and super fast. Ideal for older or low spec hardware. Use minimal memory and gives you a traditional desktop layout. Next is LXQt or LXDE. It is an ultra lightweight desktop environment, best suited for very old or low powered machines. Simple, fast, intuitive interface. Next is Cinnamon. Now this may not be shown on the slide, but it's definitely worth mentioning. Cinnamon designed for simplicity and easy of use. Feel very similar to Windows, great for the beginners. Comes with useful features like taskbar, app menu and system tray. Used in Linux Mint by default. As you can see, Linux has something for everyone, whether you prefer simplicity or customizability or speed. Let's talk about one more important aspect. Desktop environments give you a full graphical interface. With a desktop environment, you get windows, icon, menu. Everything is visual and clickable. You do not need to memorize the command. No need for the terminal all the time. You can access your files, open the application, change the settings. System management becomes simple and intuitive. Thanks for the GUI. Look at the diagram. On one side, we have the terminal where you type the commands like ls, cp and gedit. These are powerful but not always beginner friendly. On the other side, you have a file manager GUI. Click on the documents, settings, photos, music, everything just a click away. Desktop environment make Linux beginner friendly, allowing you to manage your system visually without relying heavily on the terminal. One of the biggest advantages is freedom of choice. You can choose the desktop experience that works best for you. If you prefer simplicity, try GNOME, clean and modern, or Cinnamon, traditional and easy to use. If you like customizing everything, go for KDE Plasma. or Budgie, a modern look with flexible option. And if you need a good performance, go with Xfce. It is lightweight and stable. And the next is LXQT, which is super light for the old PCs. And the best part, you can switch desktop environment anytime. No need to reinstall Linux. If you don't like your current setup, just try a different one. Linux gives you a complete flexibility, your system, your rule, your style. Now let's talk about powerful concept, virtualization. Imagine running a computer inside your computer virtually without needing a extra physical hardware. That's exactly what virtualization is. It allows you to use a software to create a virtual machine, that is a VM, that behaves just like a real computer. As shown in the diagram, you can see your actual computer is the host. On top of it runs a hypervisor or virtualization software. Inside it, you can run multiple virtual machines like Ubuntu VM, Windows VM, Mac OS. The whole process is software based, no extra hardware required. Your system CPU, RAM, and storage are shared smartly. Benefits of virtualization: run multiple operating systems on one machine, safe testing and experimentation, easily reset or restore if something breaks, and of course, big cost saving. Types of hypervisor. Just to give a quick peek into how virtualization works under the hood, type 1 is a bare metal. Runs directly on the hardware like KVM or VMware ESXi. Type 2 is the hosted. Run on top of your existing OS like VirtualBox or VMware workstation. And here the key point is virtualization help you to minimize the hardware usage with flexibility, isolation and efficiency. Whether you are testing software, running multiple operating systems or learning the system administrator. Let's now compare a virtual machine versus physical machine side by side. 4 key differences: hardware, cost, OS flexibility and setup. Hardware. Physical machine use real dedicated hardware such as CPU, RAM, motherboard. Virtual machines simulate all of this through a software. Next is cost. Setting up multiple physical machines is expensive. With virtualization, one machine can run multiple operating systems, so it cost effective. Next is OS flexibility. A physical machine usually runs just one OS at a time. VM let you run Linux, Windows, Mac OS all on the same host. Next is setup. Physical systems are harder to change and maintain. VM are easily to set up, take a snapshot and reset, perfect for testing and learning. So while both have their uses, for learning, flexibility and saving money, virtual machines are the clear winner. Let's look at the key benefit of virtualization and why it's so useful. First is save money. You don't need to buy separate hardware for each system. With virtualization, you can run multiple systems on a single machine, which save a lot of cost. Next is safe testing. Want to try a new app or update or operating system? You can test everything in a virtual environment without risking your main system. Perfect for creating lab setup and experimenting safely. Run multiple operating systems. You can run Windows, Linux or even macOS on the same computer simultaneously. No need for multiple physical devices. And next is quick rollback. If something goes wrong, just use snapshot to restore your system to a previous state instantly. It saves both time and efforts. Great for students and developers. Whether you are learning a new operating system, practicing server setup or testing the configuration, virtualization is a game changer for learners and IT professionals. So if you are into learning, experimenting or development, virtualization is must-have skill. Types of virtualization. Virtualization is not just about virtual machine anymore. There are several types, each solving a different problem in modern IT. Let's explore one by one. OS level virtualization. This is where container shares the host operating system kernel. They are lightning fast, super lightweight, and great for microservices and DevOps. Example Docker, Xfce. Next is full virtualization. Each virtual machine runs its own complete OS with a separate kernel. This provides a strong isolation. Great for running multiple different operating systems on the same hardware. Example VirtualBox or VMware. Next is storage virtualization. Combines multiple storage devices into one logical pool, making management easier and performance smoother. Example SAN storage, that is storage area network, or NAS storage, that is network attached storage. Next is network virtualization. It creates a virtual network that operates independently from physical hardware. This makes them easier to manage and more secure. Example VLAN, virtual LAN, SDN, software defined networking. And next is application virtualization. Now this may not be shown on this slide, but it's definitely worth mentioning. This type of virtualization allows individual application to run in isolated environment, like giving each app its own mini sandbox without changing anything on the host system. For example, Wine for running a Windows application on a Linux, or Snap or Flatpak. It's super useful when you want to run a specific app safely or across a different Linux distro without dependency issue. And the key point is each type of virtualization serves a unique purpose. Combine them and you get a powerful, flexible and scalable IT infrastructure. And the pro tip is a simple way to remember this. Use containers for application packaging and speed. Use VM for full OS isolation. Use network and storage virtualization for backend infrastructure. Use application virtualization to isolate and run software tools safely. Alright, it's time for quick recap of everything we learned today. Desktop environment gives Linux its graphical look. For GNOME to KDE or KDE to Xfce, each desktop environment defines how your Linux system feels and behaves. Virtualization lets you create a virtual system using software. Multiple virtual machines can run on a single device, each with its own OS and settings. Next, virtual machines are cost effective, flexible and safe. They help us to make full use of hardware while learning, development and testing risk-free. Different types of virtualization for different needs. From lightweight container to full isolated VM, from storage to network, and virtualization has a solution for everything. Today we have explored what virtualization is, its type, its benefit, and real-world use cases. Now you are better equipped to start using virtualization tool confidently. If you found this video helpful, don't forget to give it a like. Drop a comment below and tell us which desktop environment or a virtual machine are you excited to try first. And if you want more simple and practical tech tutorial, be sure to subscribe to the channel and hit the bell icon. See you in the next video. Until then, happy learning and keep exploring Linux.